Okay, so kita start dengan soalan 7.2, question number 4. So page 144. Okay, so the moon has mass of 7.35 kg and the radius of 1740 kilometer. Determine the gravitational field strength at its surface. Okay, gravitational field strength is Ag. Okay, so Ag is equal to Gm over R squared. Okay, so M is the point mass. So G is 6.67 times 10 to the power of negative 11 times with mass 7.35 times 10 to the power of 22, and then divide between radius because the gravitational field at its surface, so means that surface of the moon 1740 times 10 to the power of 3, then you will get the answer is 1.62 Newton kilo negative 1. Okay, so next. Okay, the moon has mass of 7.3, same. Okay, now the prop of mass is 100 kilo, is dropped from the height of 1 kilometer into the moon's surface. So means that this is the planet, and then this is the prop. Okay, so first position of the prop is initial position, means that here. Okay, this is R initial, and then R final is from here to here. Why? Because the prop from 1 kilometer to the moon surface. So this moon surface here. Okay, sorry, wait. Okay, so R1 is come from surface. Okay, 1 kilometer from the surface of Earth. So R1 you have to calculate from this position until the center of the moon. So I can see here, this is H, is 1 kilometer, and then this is radius of moon. Okay, so to determine R1, the R initial you have to add up radius of moon plus with height. Height means from 1 kilometer, and then R final is come from the surface of moon, so Rm is R final. The R final is equal to radius of moon. Okay, so calculate its change in gravitational potential energy. Change in gravitational potential energy is delta U. Delta U is means that U final minus U initial. Okay, U final means G M M. Okay, this is capital M over R squared. Ini final R over R. Okay, minus G M M over R initial. Okay, so I forgot to substitute negative here. Okay, actually we have negative here because the formula memang negative ya. So it's become negative GMM over R. GMM is times with 1 over R final minus 1 over R initial. Okay, so this is formula that can use to determine the change in gravitational potential energy. So now we substitute the value. So 6.67 times 10 to the power of negative 11. Mass of point mass is 7.35 times 10 to the power of 22. Test mass is 100 kilo, and then divide times with 1 over R1. Okay, R final is radius of moon. You substitute radius of moon 1740 kilometer. Okay, so 1740 times 10 to the power of 3 meter, and then radius of initial 1740 times 10 to the power of 3. You have to add up with the 1 kilo, 1 times 10 to the power of 3. Okay, so substitute here. These are initial. So when you calculate, then you will get the answer is negative 1.762 1.62 times 10 to power of 5 joule. Okay, power of 5 or power of negative 5. I think this is wrong calculation. Okay, so you calculate back and then ask check later. Okay, alright, so next. Okay, so next, if all the gravitational potential energy loss is converted into the kinetic energy, calculate the speed at which the probe hit the surface. Okay, so because dia kata all the loss converted into kinetic energy, so you can rewrite back K is equal to delta U. K is half mv squared. So delta U that we get in question B is 162 times 10 to power of 5. Okay, so they ask about the speed of the probe. So mass here must be mass of the probe. Half 100 kilo V squared. So 1.62 times 10 to power of 5. Alright, so you can determine the value of V is 56.92 ms negative 1. Okay, so that's all, and then make sure you complete your tutorial module question 1 until question 4. Okay, thank you, bye.